Hey, curious kids, Kevin here. Today on A Place Called Space, we are going to talk about landing on other planets and moons. So we know from our earlier episodes that we've landed on the moon, right, with humans. We had the moon landing. We've also landed rovers on Mars. But there are many other places in the solar system that we've landed robots on as well. So we're going to look into where we have landed things in our solar system. But before we get into that, we got to figure out why. What makes it difficult? What do we have to think about when designing a spacecraft to land on a different planet or a moon or a rock, whatever there may be out in space? What do we got to think about? Why is it hard? And what do we do to land? What are different ways that we can land on the planets and the moons? So, we know we've landed on the moon. We know we've landed robots on Mars. So why do we want to land in the first place? Right? We can look with telescopes, we can have spacecrafts that fly around it. Why do we want to go to the surface? Well, there's two reasons that we really like to go. One is to explore. Like we want to walk around, or we want to send robots to really be there and do the stuff on the ground. Like it's great to look at something from afar, but you learn so much more when you're actually there, being able to do it with your hands or with a robot, instead of just looking very far away through like a camera or a telescope. That's the first one. We want to explore. The second one is sample return. So like take samples. So we got moon rocks. We used a little shovel. We scooped them up, and then we brought them home back to Earth so that we can use them in our laboratories with microscopes and other cameras to bring them back here to Earth, because we can learn so much more because we have more resources here. We don't have to bring our whole science lab all the way over to Mars or to the moon. We just bring a little bit of the moon or Mars or some other place back to us here on Earth in our laboratories, and then we have all of the tools and the computers and all the special science instruments to help us learn. So that's why we want to go and land on the surface of moons, to explore and then to get samples. Now when we're going to land somewhere, what do we have to think about? Like what's different between the moon, Mars, Earth, other rocks that are out there, maybe Venus, another planet? What's different? Well, let's take just Earth and moon, for example. So we get the moon, Mars wants to go away from us. We get the Earth and we get the moon. So one of the things we have to look at is the atmosphere. So the atmosphere, that's what's all around us. That's what's keeping the air inside planet Earth, so we can breathe, we can live. So there's atmosphere. Now, if there's a thicker atmosphere than Earth, that can change it, or if it's thinner, like the moon, that can change it too. So the atmosphere plays into it, because you have to go through the atmosphere, or lack of atmosphere, to get down to the surface. So that's one thing. The next one, what about gravity? You know what gravity is, right? Jump up. Gravity is what brings you down. It's, if I got my little alien friend here, if I let go of this alien, what's going to happen? Is he going to go up? Beam up into outer space? Probably not. Is he going to go left, right, forward, backwards? Let's see. He falls down because gravity pulled the alien down. That little foam alien I had there. So the gravity's different. So if gravity is pulling you down, that can be a good thing or a bad thing. Like if we have a lot of gravity pulling us down, maybe more gravity than Earth, that's not good, because it's going to make us fall really, really fast. And what happens when things fall fast? They crash. Not a good idea. Or if we have a little gravity, like on the moon, if you're walking on the moon, you kind of bounce and you can kind of float around, then you can it's more slow to land on the moon, right? Because you don't have the gravity pulling you. So that's something to think about. Next up, what about where we land? Like what's on the surface? So if we look at Earth, right, we got water, we got ice at the poles, we got land. Which one do you think is better to land on? They're all different. And then lastly is, how big is our spacecraft? How much does it weigh? How much mass is there? If it's heavier, like if you drop a bowling ball on your foot, or if you drop one of these inflatable planets on your foot, which one's gonna hurt more? Don't try it. It's the bowling ball. The heavier it is, the more mass, the harder it's going to be to land, because it's heavier. And then you have that with the gravity, more mass. crazy. It could be very difficult to land on a planet or a moon. So what do we do to help figure these things out? Well, so we're looking at atmosphere first. So more atmosphere can help slow you down, right? It slows you down because there's a bunch of friction. We talked about friction before. Put your hands together. What do you feel? You feel it getting warm. So that's friction because the air is coming on the spacecraft and it gets it really warm. So one thing that we do is we have these. So this is a shield. So we have shields on the front of our spacecrafts as we go into the atmosphere, and this protects us. It gets really, really hot, so we hide behind it as we're going through the atmosphere. It gets really warm, our shield protects us. So if there's a really thick atmosphere, it gets really hot really fast. So we need a super shield to help us out. Now if there's no atmosphere, we don't need a shield. Just like the moon lander. So this is what landed on the moon, right? It came down this way. There's no shield there because the moon doesn't have an atmosphere, so it was able to just go down nice and slow. Didn't need the shield. Atmosphere. You can have a thick atmosphere, thin atmosphere, no atmosphere, and it depends on how hot you get or if you need a shield at all to help you out when you go down. So next we got gravity, right? Gravity is pulling us down. The more gravity, the faster we go. So gravity plays a factor. And then if we land in water or on ice or on land, what if it's rocks? Where would you rather fall down? If you had to fall down, would you rather fall in water, fall on the grass, fall on the concrete, fall on rocks? Which one? Probably water. Water is softer to land on than grass or land, and grass or land is softer to land on than rocks. And then ice is somewhere in the middle. Depends on what kind of ice it is. So depending on where we're going to land, that'll help us out too. And then the heavier you are, the faster you're gonna go down. So we gotta be careful because you don't wanna be too heavy. But the bigger you are, so if I had a small spacecraft or a big spacecraft, the bigger spacecrafts have more friction. So there's more shield. The bigger the shield is, the more it can slow you down. So if you have a big shield, you can slow down a lot more than if you had a little shield. So those are the things that matter when we're landing in different planets or moons or other places. So where have we landed? Well, we've landed here on the moon. We've talked about that. How do we land on the moon? So we landed on the moon with this here. And do you see anything to help us out here? So if I bring it in close, you can see some parts of it. These right here are engines. And then there's a big engine on the bottom. So rockets. Rockets is a way that we can land on other planets. So we fire the rocket as we're going down, and it slows us down because rockets are supposed to make you go up, right? Well, if you're already going down and you shoot off a rocket, it'll help slow you down, and then you can land on the surface safely. So that's one way. Another way to help slow down is that shield we talked about. The shield. But the shield only works for so long. Afterwards, you can deploy a parachute. So I don't have a parachute, otherwise I'd strap one on. You jump out of a plane, parachute. Parachutes help slow us down. And then the third one that we use is airbags, like cushions. So if you're coming down, you can use a cushion or an airbag at the bottom of your spacecraft to help squish it. Then you come down to the surface. So this is the bottom of your spacecraft, and you're coming down. Here's the planet. You just come down and you squish it. You can squish. The airbag takes that impact, the hit, and then your spacecraft's okay. That's not too bad there. Now, where in the solar system have we landed? I know I've been talking about it for a while. Let's get into it. So let's start way in the middle of our solar system, the sun. If we landed on the sun, no, you can't land on the sun. It's too hot. It's a big ball of gas. There's nothing to actually land on. What about the next planet, or the first planet next to the sun? Mercury. Do you think we've landed on Mercury? Yes, but no. What does that mean, Kevin? So we've landed a spacecraft on Mercury, but it wasn't designed to land on it. So we've got the Mars rovers that land on Mars. We want them to land on Mars. Well, we had a spacecraft that was orbiting around Mercury, and it finished its mission, and we're like, you know what? What if we tried to land it on the surface just to see what would happen? So we did, and it landed on the surface, and it lived for a little bit. It crashed, but it didn't completely break or fall apart. And then it was able to tell us, he's like, hey, Earth, I'm still here, I'm working. But we didn't send a spacecraft or a rover to land on the surface and then explore. So Mercury, not officially. Venus. Have we landed stuff on Venus? Yes, we have. Well, the United States kind of did. Russia did many landers on the surface of Venus. They were called Venera. And they landed on the surface of Venus. It was the first picture of the surface of another planet ever was Venus. You're like, well, we've gone to Mars a whole lot. It's probably easier. It is a lot easier to land on Mars than Venus. But way back when, I think it was 1976, Russia landed a lander on Venus, and then they took a photo. It was the first one that we ever had of another planet. And then there were multiple spacecrafts that landed afterwards, and we're still trying to figure out what's a good way to land on Venus. Well, like to survive, because Venus is really, really hot, and there's a lot of pressure. So pressure is like what squishes you, like if you're in a pool and water pushes all around you, that's more pressure. So there's a lot of squeezing, a lot of pressure, and a lot of temperature on the surface of Venus that melts metal. Spacecrafts are made out of metal, so we got to find a good way to keep them cool or they can last longer. So we've landed on Venus. Next up, it's over here. Don't forget about Earth. Yes, we've sent people into outer space. We need to bring them back home. They need to land and then come home to their families and their friends. So one way we've done that is the space shuttle. Got my space shuttle here. So the space shuttle, it's not flying anymore, but what it did, when it came back in, it would land just like a plane. So it would come flying in, and then eventually come and land on a runway. And there we go, super safe. Once it got on the runway, it would put out parachutes to help slow it down out of the back, but it would land just like a plane. Now, there's other ways that we can land on Earth. One of them is like this. Here is a capsule. So it's a capsule. So the people are inside here. You can see the windows. And then the parachute comes up. These parachutes that we talked about, right? So it'll come in from outer space. It'll use a shield and burn up for a while. And then once it gets further enough in, it'll deploy the parachute. And the parachute will bring it slowly down to the surface of Earth. Sometimes they splash in the water and we need a boat to go pick them up. And sometimes they land on land with airbags on the bottom. So they'll inflate some airbags and then they'll crash. The airbags help slow them down. So yeah, we've landed the most on Earth. Like we send a bunch of stuff to Mars, but it's Earth where we've landed the most things. So next up, Mars. Yes, Mars. We've landed a bunch of stuff on Mars. We've landed the Viking landers 1 and 2 back in 1970s. We've had a Phoenix lander. We've had 4 rovers that from NASA that we talked about. Sojourner, the size of the microwave. Spirit and Opportunity, the size of a golf cart. And then Curiosity, which is the size of a small car. And we got another one coming up in July that we're going to launch. And we had Insight. I forgot about that one. In 2018, we landed Insight, which is just a lander on the surface of Mars, and it's exploring. It's got a drill, a probe, an arm to take a look at some things. Whew, lots of stuff all over the solar system. Let's move on. We got after Mercury, Venus, Earth, Mars, asteroids. Asteroid belt. We have landed on 3 different asteroids. There was Eros, there was, I think it's called Itawaka, and then Ryugu. It's R-Y-U-G-U, like Ryugu. We've landed on asteroids. So those are those rocks that are just floating out there in between Jupiter and Mars. So going over to Jupiter. Jupiter's a big ball of gas. Big ball of gas. It's got our hurricane. It's been going for a while. But we haven't landed on Jupiter because you can't. But it's got these moons. It's got 79 moons. 4 are really big. Io, Europa, Ganymede, and Callisto. We haven't landed on any of them yet, but we might land on Europa in the future. I got a video to show you later about what that might look like. So Jupiter, no. Next up, Saturn. And yes, we have landed not on Saturn, but on one of the moons of Saturn. Can you see this over here? This says Titan. Titan is one of the moons of Saturn, and we've actually landed on Titan. It has liquid methane ethane lakes on the surface. So our lakes here on Earth have water, drinkable water. Sometimes there's salt in it. You don't want to drink the water in here. It's bad. It's methane. It's liquid, but we landed on the surface. We didn't actually land in the water, but we landed on the surface. We landed on the rocks. I got a video for that one too, after I tell you why I think Titan is so cool. Titan is one of the best places in our solar system to find life. In 1 second. I had to go wake up some life. So this is Titan. This moon here, this is the reason that I named my dog Titan. Oh, he's so sleepy. He was sleeping. See, he just wants to go back to bed. But this is Titan, and I named him after the moon of Titan at Saturn because it's so interesting. It has the best place, one of the best places to find life in our solar system. And he's just so tired. Say hi to everyone, Titan. Hi. Oh, we can let Titan go back to bed. Here you go, buddy. Thanks for playing. All right, so we've landed unintentionally or not specifically on Mercury. We've landed on Venus, Earth a lot, the moon, Mars, asteroids, and then the moon, Titan. We've also landed on a comet. So comets are these big dirty snowballs that are out in space, right? We've landed on a comet. So cool, just a couple of years ago. I got some videos of what it was like to land with parachutes, heat shields, rockets. What does it look like? So let me show you a few of those different ways that we can land. Because depending on where we are, we need to use different things. The gravity might be different, the atmosphere might be different. So let's check it out. So I need to bring up this, make me smaller. I'm working on it. And there we go. Now I'm getting smaller. Whoa, there's like so many Kevins. What's going on? So we looked at this one a little bit earlier. So this is Mars Pathfinder. This one talks about in 1997 where we landed using just airbags. Well, a heat shield. So heat shield, big old shield like this, and then airbags to help slow us down. So let's take a look. All right, so we came in. We're coming in. We got those airbags out after the heat shield. And then we dropped our airbags and they're just bouncing, bouncing, bouncing. And we're like super happy because we were able to make it happen. We jumped forward and that is what it looked like once we got to the surface. So we were bouncing on rocks. Rocks, not so great. Now, let's see another one. So how did we land? These are, so far have been on Mars. So we got that heat shield coming in so you can see it. And then the parachute comes out, so we're using a heat shield and a parachute here. And now we keep on going, it's getting super fast. And then soon the airbags are coming out. So it's coming down, and then the airbags get big, so we need airbags to help us out. They'll jump up in a second. There they are, and now we're bouncing. Bouncing, bouncing, bouncing. So that's a couple ways to do it. So I talked about, let's do this one. Venus. Okay, so how did we land on Venus? This one's super cool. So we let go of our lander and then it released a bunch of parachutes. So remember, Venus has a really thick atmosphere. So once we get through it, it's also really hot. So you don't want to take too long to go through the atmosphere because you're just going to burn up. You're going to get way too hot. So you kind of want to go quick. But it's so thick that eventually you don't need parachutes. Eventually we just drop our spacecraft, our little probe, our lander there, and it can fall, and it's falling slow because it's falling through a really, really thick atmosphere. And then there we go. we land on the surface of Venus, and then here's the first photo that we have of another planet from the surface. It's super cool. That was the first one that we ever had. And that's how we landed on Venus. Oh, stay in here. I got more to show you. So, we've seen this one. Okay, this is what I want to show you. This is Europa Lander. This is the last one we're going to show today. And I worked on this mission when I was at NASA, and Europa is the best place to find life in our solar system outside of Earth. So we've got an orbiter here, and then we got Europa Lander inside the back, and it's going to shoot out. Once we get close enough, there we go, it's shooting out. And now here's our lander. So you can see that there's a rocket here in the back. So Europa doesn't have an atmosphere, so we don't need a heat shield. We don't need parachutes, because parachutes only work if you have air. And now the gravity at Europa is a lot less, so we don't have as much pulling us down. So as we're going down, we use these rockets and we slow ourselves down. Next, now we're just kind of slowly hovering as we're coming in. Then we start to do sky crane. This is like how we landed the Mars Curiosity rover on the surface. You lower it down on a rope with engines and you're just hovering. And then once you touch down, you can cut that rope and then you can fly away. It's bringing me back. So there's many different ways that we can land on the surface of a planet or a moon, right? We can use parachutes, we can use the heat shield, we can use airbags and rockets to help slow us down so we can land safely on the surface. Right? So we want to go there because we want to explore, and then we want to get samples and bring them back here to Earth. We've brought back asteroid samples, comet samples, moon samples. Next, we need to do Mars samples. Right? But what about humans? When will humans go to Mars? I saw that question come in. We're thinking around 2030s is when we're going to get the humans to Mars. I feel like it's going to be a little bit longer than that. Probably like 2050s until we actually get humans on Mars. That could be you. You could be one of the first humans on Mars. You're going to be the right age when we get to be that time. So if you want to be a Martian astronaut, keep learning about these space concepts, these space lessons. Keep trying hard in school, and maybe one day you're going to be the person walking around on Mars, and you get to tell us all about it. I think I saw maybe a couple more questions that I want to check out real quick. Will a rover ever go to Mercury? Not yet. So Mercury, we plan to go to places in the solar system that are trying to answer the most important questions we have, and we haven't found Mercury to be a place that can give us more answers than somewhere else yet. So no planned rovers to Mercury. It's not that interesting than some of the other planets and moons that we want to go to. Humans walking on Mars, yep. Will humans ever land on an asteroid? One day. We haven't done it yet. We're still working on going back to the moon, right? But once we do that, we do plan to land on asteroids at some point so we can be there just like on the moon to take samples, do instruments ourselves, and just advance and explore ourselves as a society. Why did they retire the space shuttle? So the space shuttle, the main purpose of the space shuttle was to build this right here, the International Space Station, right? So once it finished that, it actually ended up costing us a lot of money to do the space shuttle. And one of our presidents decided we didn't think that we wanted to keep on spending money on the space shuttle because it served its main purpose, and we wanted to put the money for taxes elsewhere. So then we started to pay Russia to use their rockets to go into outer space. They retired the space shuttle in 2011 because we didn't need to build the International Space Station anymore, and we didn't just need the space shuttle to help launch satellites. We had other rockets that could do that. How do we know what the atmosphere is like? Good question. So like the moon or Mars, what do we know about it? So before we land on another moon or a planet, we like to orbit around it or study it first. So we can use telescopes from here on Earth or telescopes that are orbiting Earth to look at the atmosphere. Then we have spacecrafts that are like flying around it. So space shuttle didn't do that. Spacecrafts that are flying around it, they can study the atmosphere and tell us different things about it, like how thick it is and what it's going to be like when we land inside of it. There we go. Landing on planets and moons and asteroids and comets. Thank you very much for tuning in. Click that thumbs up if you liked the video, and make sure you click subscribe below to let me know that you are a fan of A Place Called Space. Now, I've got a big announcement for everybody. So if you're still tuning in, this is great. We have been doing this, or I have been doing this, and you have come along with me for the last couple weeks, and we've been doing every single day A Space Called Place during this COVID-19 lockdown while schools are closed and we're homeschooling and learning remotely. Now, I love teaching you about science and space. I do. There's so many other aspects to science, right? There's different things besides just outer space, but I love outer space the most. So I want to give you the opportunity to learn about other aspects of science and life in general. So I'm going to be coming to you live every Tuesday and Thursday from now on, starting next week at 9 a.m. Pacific time, or Kevin at 11 for everyone in the Central Time Zone. Tuesdays and Thursdays, we're going to do the same thing, teach you about space. And then Monday, Wednesday, and Friday, you can learn about something else. And you're like, but Kevin, what else can we learn about? There's so much more, and in the description of this video, I've put links to what my friends are teaching. I have my friend Tracy. Her name is Inspector Planet, and she talks about our planet, the environment, and animals. All right? There's also Mallory, Miss Mallory Adventures. She talks about nature and does experiments as well. Then there's Emily Calandrelli. She's known as the Space Gal. She does at-home experiments on Instagram Live. All of these links are down underneath this video. And then we got Janet. Janet's a good friend of mine. She's known as Janet's Planet, and she does interviews with astronauts and other scientists and researchers all about outer space. And even me, I'm going to be on hers next week at some time, talking to everybody about who I am as a former NASA rocket scientist and how I got to be a NASA rocket scientist. So from now on, A Place Called Space is going to be going live every Tuesday and Thursday at 9 a.m. Pacific time, and I'm excited to see you then. Again, click that thumbs up, click the subscribe button, and keep looking up.